Hello everyone and welcome to the 29th meetup of Kaggle Days Meetup Delhi NCR. Today we are having Andrey with us. Andrey is a 2x Kaggle Grandmaster and he's a Grandmaster onto the notebooks and discussions. So today he's going to discuss about data visualization in data science. So I'm pretty much excited about the topic. So over to you, Andrey. Now you can continue with the session and best of luck.
Thank you. Okay, let's start. My name is Andrey Lukyanenko, and today I'll give a talk about data visualization in data science. My thanks to the hosts for making this talk possible. A couple of words about me. As it was already said, I'm Kaggle Notebook Grandmaster and hold the first place in the ranking for a long time. So I have some thoughts to share on the topic of visualizations. And currently I'm working as technical leader in a research and development team in computer vision and also use data visualization at my job. Now let me present you the content of my talk. At first, of course, I will speak about data visualization in general, what it is, why is it useful, how it can be helpful for everyday tasks. Next, I'll talk a little about the history. The history of data visualization is a vast and huge topic, and well, I can't cover all of it in my talk, so I will highlight only several interesting or important points. Nowadays, people usually use specialized software to make data visualizations, and I will show some examples of them. Next, I'll talk about different chart types. There are a lot of different charts, and there are many ways to categorize them, and we'll discuss them and why they are used. If you are doing a small exploratory data analysis or do data visualization from time to time, then you don't really need to spend a lot of time on developing your skills for it. But if you aim to do data visualization professionally, you need more skills, and we'll discuss them. The aforementioned points were more about theory, but I want to talk more about practice. I'll show multiple examples of taking a mediocre visualization and improving it, and we'll see how it improves step by step. And then I'll show specific examples of using data visualization for machine learning, because here it will be about visualizing the models, interpreting them, and stuff like that. So, what is data visualization? Formally speaking, data visualization is a graphical representation of information and data. Now, our eyes are drawn to colors, patterns, and shapes. Using them, data visualization grabs our interest and keeps our eye on the main message. When people see a chart, people quickly see trends and outliers. When people see these things, they internalize them, understand them. And this is how storytelling works. This is much better than staring at a huge spreadsheet with tons of data and understanding nothing. I think many people had that experience. But it isn't simply as easy as just slapping a random chart onto the data. To create an efficient and effective data visualization, we need to balance the form and the function. A practical but plain graph could be too boring to capture the audience's attention. On the other hand, a stunning visualization could fail at delivering the right message and information. The data and the visuals need to work together, and there is an art of combining great analysis with great storytelling. Now I'll show you two practical examples where data visualization shines compared with looking at data statistics. Here is the first one. This dataset is small and it is called Anscombe's data quartet. It shows several pairs of x and y's which have different values but have the same statistics. As you can see, each x has the mean value of 9, each y has the same mean value of 7.5, and the correlation between them is the same. But if we draw the plots, we see a completely different picture. In the first case, we have a scatter plot, which is what we would expect from the data having such a good correlation. The second plot has the values increasing and decreasing. The last points have linear relationship between the two variables, though the coefficients are very different, and we have one big outlier. So if we have this small table, we can see the difference in the values and and we could expect these problems. But if we have a data set of thousands or millions of rows, it would be impossible to look at it manually. Data statistics would be not very useful, so data visualization is really useful in such cases. And there is another artificial and funny example. This dataset is called the Datasaurus dozen. As you could guess from the name, there are 12 small datasets. Each of them has the same statistics like mean, max, and so on, but they're very different, as you can see. There are stars, circles, even dinosaurs. Yes, so this is another great example of the fact that we need to do data visualizations to understand the data. It is possible to talk a lot about history of data visualization, as I have already said, but this isn't really in the scope of my talk, so I'll mention a couple of important points. If you want to read more about the history, you could spend some time reading this slide. But I want to show this amazing visualization. This is the Maynard diagram. It shows the losses suffered by Napoleon's army in the 1812-1813 period. There are 6 variables plotted here: the size of the army, its location on a two-dimensional surface, time, direction of movement, and the temperature. The line width illustrates the size of the army at a given point of time, and the temperature suggests a cause of the change in the army size. So we see a multivariate display only on a two-dimensional surface, and we can see the whole story immediately. Tufte wrote in 1983 that this may well be the best statistical graphical ever drawn. Well, maybe now there are some bad things, but it is really interesting and impressive nowadays. Speaking of Tufte, John Tukey and Edward Tufte are very famous because they did a lot to progress data visualization. Tukey with his statistical approach of exploratory data analysis, and Tufte with his book, The Visual Display of Quantitative Information. They paved the way for refining data visualization techniques for modern statisticians. In his book, Tufte defines the principle for effective data visualization graphical display. It has a lot of great ideas, but they can be distilled into the following points. Maximize data ink ratio. Data ink ratio is a term used by Tufte a lot in his book. He was against using excessive decoration and preferred simple and functional charts. Minimize light factor. This means avoiding distorting what the data has to say. Minimize card chunk and use proper scales and clear labeling. Later I'll show some examples illustrating these points. Now I want to talk a little about the software. Some of the most beautiful visualizations are done by hand or maybe using visual editors like Photoshop. But in real world, people usually prefer to use software as a more practical approach, which also allows to reproduce visualizations easily. Let's start with Python as a commonly used programming language. There are a lot of packages in Python, and Matplotlib is one of the most popular, and is maybe even the one who is the most popular. It's possible to do almost anything in it, but it may require a lot of code. Those who made plots in Matplotlib really know this. But one thing it isn't very good at is making interactive plots. While it's possible to introduce some measurement of interactivity to charts, it would be very difficult, and well, there are better tools. For example, there is Plotly. Plotly is meant for interactive visualization, pop-ups, filtering, zooming, and many other things, as you can see on the screen. There is a huge ecosystem around it. For example, there is even Dash for creating dashboards. Of course, there are multiple libraries like Bokeh, but I can't enumerate all of them. But there is one more Python library that deserves a separate mention. It's Altair. It is one of the few Python libraries that are based on the grammar of graphics. Grammar of graphics is another huge and separate topic which I can't discuss in details, but basically it is a framework which follows a layered approach to describe and construct visualizations or graphics in a structured manner, so that we describe layers, we describe colors, scales, and other things separately. Now let's move to another programming language, it's R. R is another popular programming language in data science, and the main library for visualizations is ggplot2. You may notice that this plot and the previous one are similar. This is because ggplot2 is also based on the grammar of graphics. Now, while a lot of people use programming languages for visualizations, there are many solutions for making good looking visualizations without a code. Tableau is one of the most famous ones. It is often used to make dashboards. It can be used to make exploratory data analysis. There are a lot of ways to using it. It has huge capabilities, allows to publish your visualizations to wider audience and so on. So it's great. And the last thing I want to show is D3.js. It is a JavaScript library for producing dynamic interactive data visualizations in web browsers. Many stunning visualizations in the internet are created using it. As you can guess, you have to know JavaScript to use it, and it can be very complex, but it produces really amazing visualizations. Now we talked about more general things, and it's time to talk about the types of the charts. There are, of course, a lot of different types of graphs, and there are many ways to categorize them. First of all, we can simply enumerate all chart types: box plots, bubble charts, bar charts, and everything else. Just enumerate them. But if we want to have some structure in this, we need to categorize them. There is one cool site which is exactly about this. It shows what charts you can use when you have different types of the data. So this categorization is based on the nature of the data. For example, we may have some numerical variables in our data set, and how can we plot them? If we want to plot a single variable, we can use anything which shows the distribution of the data, histograms, density plots, stuff like that. If you want to show interactions between two variables, we can use histograms again. We can use violin plots and other things. We can use area plots and so on and so on. If we have multiple variables, we can use, for example, stacked area plots, or rich log plots. Now, if we have categorical features, we have different variety of options. The most default one and is the most known one are bar plots. But when you show several variables, you can also use Venn diagrams, tree maps, heat maps, and so on and so on. But also, maybe you have data which isn't strictly speaking tabular and have samples connected to each other. For example, you could have network data. Of course, you can use network graphs to plot it, or you can use something to show the hierarchy of the data and use tree maps, dendrograms, and so on and so on. So this is categorization based on the nature of the data. Another type of categorization is based on what do we want to show. If we want to show the distribution of the data, again, we use rigid lines, box plots, histograms, and so on. If we want to show the correlation between two or more variables, we use heat maps, scatter plots, and other stuff. If we want to show the ranking of values, we can use word clouds, bar plots, lollipops, and so on. So the selection of the plots depends on what you want to show. Now, I have already spoken about the software, and I think it's already obvious that making good visualization isn't really trivial. And now I want to expand on this. If you want to be professional, first of all, you need general data visualization skills, like knowing when to use specific chart types and how to make visualization look good. But this is only first step. If you plan to make dashboards for users or customers, you need to make them presentable, easy to use, and informative. You need to know stuff like graphical design, interface design, UX, UI, so that people can understand what and where there are things, and it will be easy to use. When you're making a presentation, you need to be able to tell a good story to make the audience interested in your talk and follow you. Colors is another huge topic. There is a separate color theory on when colors fit together, when to use which color schemes, how the colors can be used to show some message, and there are many other things. Accessibility is another important topic because some people have difficulties in distinguishing similar colors, so maybe you need to use contrastive colors, maybe you need to use more shapes, patterns, and other things which distinguish the data points and not only the colors. And style guides is something like more formal. They look like this. Style guides are standards for formatting and designing representations for information like charts or other things. They define what chart should be used in specific cases, what colors should be used, and stuff like that. Usually, there are some templates to make it easy for people to apply the standards from the guide. These guides fit within an organization's design system. For example, they specify how elements like a logo, brand, colors, and language apply to charts. If you ever looked at visualizations by some popular companies, then you could notice that they look similar, and this is done thanks to these style guides. So, I have talked a lot about theory. Now, let's talk about practical examples of improving your visualizations. First of all, let's think, what are the most common ways to improve the visualization? Obviously, you fix some errors which exist on your plots. Then you may try to make it look better, more presentable. One that is really important is you often need to fit the chart audience. Some people prefer to see a detailed analysis and see many plots which you did, what you did the analysis. Others want to see the results and see only what you show after your analysis. Some want to see precise numbers, others want to to hear a story, and so on and so on. It is good to know your audience and prepare the plots for it. And it's a good idea to highlight important thoughts. Most of the following examples are from a wonderful book, Storytelling with Data by Cole Nazbaum Knaflik. So we have this plot. Let's try to understand what does it show. It shows the results of some kind of survey. What is this survey? I can't understand from this chart. Okay, so I know the question was how do you feel about doing science? Okay, and there are 5 answers. Uh, uh, it's possible to compare the charts, but well, it's not very good. Let's see what could look better. Here, this is a better version of the previous plot. The first important thing is that we have the message at the top of the chart. The message is the pilot program was a success. Aha. So from this sentence, we understand that there was some pilot program, there were some results, and after the pilot programs, the things became better than before. Next, we see two main colors and immediately understand that gray is before, blue is after. Also, we see the source of the data, the number of people who took part in this survey. So let's see again the previous version and the current version. Here we see the structured information. It's much easier to compare the data and much easier to see that there are better results of this pilot program. Let's see at another example. Here we have all the necessary information, but we have too many information. We have the chart, we have several pieces of text, and well, when you look at it, it's difficult to understand where should you start looking at. Yes, so it's good idea to add contrast. As you can see, we changed some fonts, and while most of the text is gray, the most important parts are black. And the same in the chart. Several bars are gray, but 3 most important ones are black. So we see what is the most important attribute, we see what the survey shows, and we see which is also important together. This looks much better and more presentable. Here is another example. We see a simple chart, and it's difficult to understand what is going on. We see that there are something was received, something was processed, and the number of received something is higher than number of processed something, and we have no idea what does this mean. So here are some logical improvements. We see the main message, we see the problem, and we see the additional data. So there was some kind of ticket system, and everything was okay. Then 2 employees quit in May, and we can see that the rest of the team can't keep up with the volume of the tickets. And so we see the problem, we see the situation, we see the possible resolution. This is much more clear and understandable. Yes. And the last example, we see a comparison of distribution by customer segment in US population and the customers of some company. But it's okay, there are a couple of glaring problems. First of all, the texts with labels are misaligned, and when you notice it, it's difficult to stop noticing it, yes? And there are too many colors, yes. Sometimes there are too few colors, and sometimes there are too many colors. Here is the better version. First of all, the text is aligned. The important parts have the different color, different boldness, different position, and we can see that we need to compare these parts. So it's much better than the previous version. So as you can see, sometimes we have too few colors and we need to add more. Sometimes we have too many colors and need to might have less of them. It's very important to show the correct message, yes, and so that the people know what should they look at. Now I want to show several negative examples where something is very wrong. First is this small video showing one of Kaggle notebooks. As you can see, a person made dozens of plots. Well, this isn't really useful. You see dozens and dozens of similar plots. They don't have labels, they don't have any descriptions, we don't know what's going on, there are no explanations, so this isn't very useful and it isn't really presentable. If you want, first of all, it's better to show only several plots than dozens of them. And if you want to show your analysis, you need to add some comments, some explanations, stuff like that. Another thing is this plot. Do you remember that at the beginning of my presentation I talked about Tufte and his principles, and one of them was using clear labeling? Well, can you guess the values of these bars? Well, let's take the last one. Is it 30? Is it 35? Maybe 35? No. You can notice that there is some gap between the lines. So in fact, this bar means 40. Yes. So, and this is why a lot of people criticize using 3D plots. Maybe 3D plot is justified when you can show interactivity, when you can turn it every way and show it how you want. But if it is static, then it's better not to use it because it's not really clear what the values are, and it's difficult to compare them. Here is another more glaring example. First of all, pie charts, well, the use of pie charts is a hot and debatable topic in data visualization. Some people say that no one should use pie charts, that they are very bad and they should be never used at all. Some people say that you need to know how to use them and when to use them. But at least all of them agree that you need to think before applying them. The main problem of pie charts is that it's difficult to compare the values. And here we see a pie chart in 3D space, so we can't understand how the values correlate between each other. Is B twice more than A, maybe 3 times more, maybe half against it? We have no idea, so please don't do this. And here is an example where maybe some person was malicious in showing the data. As you can see, we have some kind of values and the huge difference between them. But is it really huge? Let's see. Here we have 16,000, here we have 15,000. The difference is maybe 10%, but the plot shows the huge difference. The problem here is that the person cut off a big part of the chart and shows that the difference is high. This is one of kind of bad practices when you use data visualization to mislead people and to show them some specific message which isn't really true. Please don't do this. This isn't a good practice, so better not to do this. Yeah. Now I want to show several practical examples. These plots which we see are from Kaggle notebooks and done in Python and Plotly, so it can be done in practice, but I really like how they look and what information do they show. First of all, we can see that this chart follows almost all good practices which I mentioned before. We have a clear title which explains what we see. We have some contrast between colors, so we see that one color is students, another color is data professionals. We have explanations about some important part of the chart, and we see that there is highlight of the important text. In total, we see several variables, the NH, the values, and the category, whether this is student, data professional. So this chart has a lot of information in it. The information is clear, the chart looks good, so it's really a good example. Here we have another great example. I really like these types of charts because they are really great at showing the proportions of values. So here we see different titles or professionals, and we see the educational qualifications for them. If we use not the absolute values, not the relative values, but absolute values, then I suppose the bars would be very different. It would be quite difficult to compare them with each other. But here we take relative values, so we can see that in research scientists, you need like 55% of research scientists need doctoral degree. For statisticians, this is much lower, and so on and so on. So it's easy to compare, easy to see the flow between different qualifications. So I really like this example. Here is a simple seaborne pair plot, but I really admire this type of chart because it is very simple to use. It looks very great, very good, and it shows really a lot of information. We have distributions for each variable. We have scatter plots with information how features correlate with each other, and all the values are separated by their classes, so we can see some kind of clusters of the data. So I really recommend using it when you want to look at some kind of data set. And this is quite a different plot from what I have shown before. And this is a map. There are many ways to plot maps. In Python, there are several libraries, but this is a software called Kaggle from Uber, and it supports showing millions of points at three-dimensional surface on Geo on our planet. It's really useful and it looks really great. So if you need to show a lot of points on the geo data, it's a very good tool for this. And now it's time to speak about visualizations purely for machine learning. I suppose the most popular idea which people use visualizations for is interpreting the models. Because if you have some linear regression, it's quite easy to understand what features are the most important. You simply look at the coefficients. But if you use neural nets or tree-based models like decision trees, random forest, gradient boosting, and others, it's much more difficult to interpret the values. And there are multiple libraries which help them. Sharp is one of the most famous ones, and that shows how the values of each feature influence the model out. Let's see at this plot. We see here at the left part of the screen the list of features. The values at the bottom of the screen show the impact of model output. It's like the higher, for example, we could have a binary classification, or maybe we could have regression, and higher if impact on model output is positive, then either the regression output is higher or classification is more near to 1. Yes, and it's lower, and then then we have the regression showing low values and high probability of 0. And the color shows the feature values. What does this mean? For example, low values of budget have negative impact on the model output. High budget values have a positive impact on model output. And if this feature has the opposite influence on the target. Another popular tool for visualization is showing plots after dimensionality reduction. For example, here we can see that there is some data set with text data. We applied some vectorization or even trained model vectors, for example, word-to-vec or something like that, Usually they have a huge dimensionality, maybe 300 values for each feature, for each vector. But then we reduce the dimensionality to 2 and we can plot it in 2 dimensions. And here we can see different clusters when groups of words are similar to each other, like something about Paris, something about Python, and so on and so on. So it could be interesting to analyze our dataset and the embeddings which were learned from our dataset. Here is a different thing. If you run a lot of models, it's quite important to be able to compare them in some way. And if you run long training, for example, with neural nets, it is very useful to be able to show the plots how the model trains. And if you use some kind of hyperparameter optimization, it's interesting to see how combinations of hyperparameters produce better or worse values of the model. And this screenshot is from the tool called Weights and Biases, which is one of many experiment trackers. There are a lot of them, but I really like this one. Yes, and so we can see that there was some kind of data set. We did a hyperparameter optimization. We can see how some hyperparameters, whether they correlate well or not with our target variable, and we can see the best accuracy of the model. So it's quite useful to analyze how the model was trained. Here we can see SHAP again, and it's used not simply for tabular data, but for images. So we can see, for example, maybe the model was for multi-class classification. We show some image to it, it makes classification and shows that, for example, for class strawberry, this part of the image is important. Well, it's true. But when we try to predict some classes which are not presented in the image, we can see that there are no colors on our images. Speaking of images, there is a tool called GradCam, and we could simply take the weights from separate layers of our model and see how they work. So we can see that we have several convolutional layers in our model, and we can see that how different activations look like. This isn't maybe inherently useful, but it's fun to see how the model works with our data, how it understands it, how it works with the part of the images, and maybe we can know that some part of the image is important, some part of is not. Maybe it could be used for data augmentation. And this is another fun tool. It's called the Neutron. It's a tool for visualizing neural nets. Some libraries have inbuilt tools similar to this. For example, in Keras, you can plot the model architecture easily. For some other models, it's more difficult. But also, we can upload some kind of NNX model, so we could convert the model to NNX, and still we could upload and see the structure of this model. So it's easy to show other people how your model works. This is in general my talk. So we talked about the theory of data visualization, why is it important, and how it can be useful. We talked about a little about the history. We talked about software used. We talked about the practical aspects and how some certain graphs could be improved if we use best practices. And we saw some examples of data visualization for machine learning. Of course, there are much more things which could be spoken about data visualization, and if you're interested in it, here you can see several pages with references for some interesting things, for sources which I used, and stuff like that. And for example, if you're really interested in pursuing data visualization as your career, it is a good idea to join this society, Data Visualization Society. It's a society of people who are professionals who work on creating cool and interesting data visualizations, and you can always ask for help there. So here is my contact information, and this is my talk. Thank you for your attention.
Hey, thank you, Andrey, for such a useful talk around the importance of data visualization and like how it's important to do it better, right? Like a lot of people do data visualization, but the way they do it, the how they highlight the main things is what you highlighted majorly. So thanks for that. While I was watching your presentation, it's like one fact is same thing could be represented in multiple ways, and that's where the art of data visualization comes into picture. So when someone is just starting their journey in data science, like someone who is fresh into college or someone who is just trying to enter the data science domain, they are very much confused that where should I start, or do I need to do modeling at the first place? Do I need to use neural networks at the first place? So I think data visualization can help them to understand this field better when they're just trying to enter. So what are your views around like the for the folks who are just entering this data domain, and how data visualization can help them understand this domain better, or maybe help them to gain their interest in this domain as they go?
I see things that data visualization could help people to understand some concepts better. Because, for example, speaking about me, when I was studying in university and when I learned statistics and the different theory of calculus and other things, often I didn't understand many things. I wasn't interested enough in this. But after some time, I have decided to refresh this knowledge and I opened Khan Academy. This is a site which teaches math with amazing videos. They have cool visualizations for everything. And when you look at visualizations, you understand things much better and you are usually more interested in understanding it. This is even relevant for understanding how machine learning models work because, for example, if you look at formulas of some kind of SVM, for example, it's maybe difficult to understand it, but when you see these hyperplanes separating the features, the points in the space, you understand it much, much better. So I think that when we have materials which good data visualization, they help you understand material better and motivate you to do more and study more.
Exactly. And like you also touched upon that before modeling, if we do a little bit of data visualization, it really helps us to structure our approach better, right? So even when I was working in certain projects, or I have seen certain teams work on projects, like asking the right question, like sometimes people are too much into machine learning models, too much into directly applying the machine learning models. And if they start with a data visualization approach, they at least get to understand that which is the best question or what can be answered from the data set that I have. So data visualization definitely helps there. And like any journey of yours, like where data visualization helped you to understand, like maybe when you just saw the data you were a little bit confused that which approach should I take or how should I go ahead, but as you utilize data visualization skills, you try to understand which features are important or which approach should I take. So any anecdotes around that of your experience around working with data science projects?
Yes, I think there was an interesting story. It was in one of the companies where I worked. We had a database with different tables which we used for data modeling, and there was one data table where there were many features created by feature engineering. So it was contributed by multiple people. This was a huge table with maybe 200 or 300 features which were created long ago. They were calculated each month, and it worked okay. Everyone was okay with that. But one day I was interested in and decided, well, I'm using this data, but is the data okay? I'm not sure. So I decided to visualize the data. We had really a lot of it, so I calculated, for example, different statistics over each month and make the plots over time. For example, so I saw that, for example, this feature had specific mean values each month, had specific quartils, max mean values. And when I plotted it, and I have found that several features changed abruptly at a certain point of time. So like they were some kind of trend there was, and then they dropped or increased sharply. And it was very strange. We tried to understand the problem and realized that at some point the calculation of several features stopped. And so the values of other features which were dependent on them changed. And no one noticed it. We trained the models on the wrong data, and sometimes they didn't work well. So we were very glad that we found these problems. We fixed the calculation, and later the features became better working again.
Got it. So yeah. That's the power of data visualization, we can tell. So it's like a lot of the students or a lot of the folks who are trying to do data visualization, or they are like just going back to very basics, like somewhere they're very confused that should I go with R or should I go with Python for data visualization, though we know that both the languages have their own benefits and have their own advantages. So do you have any suggestions around that? Like might be certain things which works very, very great in Python, like around data visualization, or certain things which work very great in R. Any suggestions or any like experience that you had around that?
Yes, I think that debates between those who use Python and those who use R are very hot, and there are many holy wars between those who use them. I think that it depends on the project which you use, which you work on, and on the infrastructure of the company. For example, if you work in a company and no one uses Python, everyone uses R, it would be strange for you to use Python, and the other way. In your personal project, I think it doesn't matter what you use. You should use what you're comfortable with. For example, personally, I tried R and I tried it multiple times, but it wasn't very comfortable for me. But I know a lot of people who make like amazing visualizations in R very easily. Yes, and so I think that R is well, if you know R, it's better to do visualization in it. But as for Python, I think one of the problems, additional problem, is that a huge variety of libraries. There are Matplotlib, Seaborn, Bokeh, Plotly, Altair, and so on and so on. I think the default approach would be to use Seaborn because it's a convenient wrapper of Matplotlib. It produces nice plots. It's easy to use, so it should start with it if you try Python. And only if you understand that this isn't enough, you should try Matplotlib or some other stuff. On the other hand, for example, if you switch from R to Python, maybe it would be easier to use Altair for you because the syntax is quite similar to ggplot2 thanks to the using the grammar of graphics. So it depends, but for example, but as default, use the language which you know, yes, and use the high level library at the beginning.
Makes sense. Like the things where you're more comfortable would help you to achieve better results. Exactly.
Yeah.
So around that, like we have a lot of tools like Power BI and Tableau coming into industry. Like a lot of organizations are using it to generate visualizations and to generate insights. So like, do you think like this helps the like very much like the folks who are not very much into coding, the folks who are not very much into R and Python, like softwares or platforms like Power BI and Tableau are giving them an edge around like how to understand the data better, how to generate visualizations, how to generate like business insights from the data that they have. And a lot of the folks are moving into data analyst roles nowadays with the help of these softwares, which are not very tech, very not techy, but these are really helpful to at least get their hands dirty into the data domains.
I think that Tableau and other software is really great because let's remember if you want to do data visualization, then our goal is not to write some kind of good code which makes a nice visualization. Our goal is to make a visualization. If you can spend 1 minute doing it in Tableau and half an hour doing it in Python, better do it in Tableau. Yes. So don't remember the goal. And if you have an average user from a big corporation who doesn't know programming languages, it's much easier to teach him using this software than making him learn the specific programming language. On the other hand, if you are a data scientist, then maybe it's better to use programming languages. And the main benefit is that you can reproduce your visualizations easily. So you can reuse your code in separate projects. You can use it again and again, and you can integrate it somewhere. But if you simply need to show something, software is useful. And let's remember one more important thing: the data often isn't in vacuum. It stays somewhere. It could be in some database, and often Power BI, Tableau, and other things are integrated in the database and have the direct access, and it's much faster to get the data. But if you use Python, you need some kind of API to access the data. It could be slow, it could be difficult. You could need some additional access request to submit to IT department. So it could be really much more difficult, much slower. So I think that good software for visualization is really great, and it's okay to be used.
Perfect, perfect. So another thing, like Ramsey was asking, what is the best approach to make animated graphs visuals? So, like, any tips or any suggestions on that?
Okay, if you use R, there is this great library Shiny. It's for making dashboards, and it can provide some interactive elements in the animation. Yeah, so Python, I'd say there are maybe three main things which I'll mention. First of all is Plotly. That's the library which I mentioned. It can provide any interaction you want. It can provide pop-ups. It can provide animation over time and stuff like that. It's really useful. It's really easy to use. Well, sometimes not very easy, but it's very good for this. Altair is also allows it. I was able to do some kind of complex visualization and animation using it, so it's great. And there is a completely different tool called Streamlit. Streamlit is kind of front end, for example. You could say it's really a kind of front end when you can easily plot everything in the web version, and you can pass the simple plots. You can add the drop down lists. You can add some conditions. You can like really easily integrate some kind of programming filter and elements and the plots. So it's really great. When I started using it, I was really excited, and I was able to show some dashboards with it, and people really liked it.
Makes sense. Got it. Thanks. Like another question is like when you started your data science journey around, like how was your journey around, how you get started, and like because many beginners or many folks who are just trying to enter the industry, they always think that modeling is the first step, or I need to utilize very complex things, then only I could get a job, or then only I could get an internship. So like, could you please explain your journey around your data science like data science domain, and how do you think like making the basics clear, because we like a lot of the folks are running behind those very cool algorithms that they hear, but somehow due to this thing they are missing out on the basics, which might not be which they think is okay for now, but for the long run it's not useful for them. So any suggestions or any tips which you can relate from your journey and would love to share with the community?
Of course. So at first, about my journey, I have after my education is economist, and when I was studying in university, there was no programming at all. There was only SQL, but only it. So at first, I worked for more than 4 years as a ERP system consultant, like SAP and stuff like that. But it was consulting. It was stressful. There were overtime, and it wasn't really fun. So after some time, I have decided that I don't want it. I have started looking for other opportunities. I tried some things and failed, but at last I have found about machine learning, about big data, and I got really excited about it. That was summer of 2016. I left my last job in consulting and I have decided that now I'll study machine learning and I'll find my first job in a couple of months. Well, maybe in 4 months. Okay. So, well, my background was that, as I repeat, no programming, weak math. Well, not weak, but I studied a lot of math in university, but I was kind of bad in it because I often wasn't motivated to study it, and it wasn't very interesting. So maybe I was the best in calculus, but very bad in linear algebra, for example, in stars. So I have spent the first month on studying Python. I have spent the second month on studying machine learning course by Andrey, the popular famous course. On the third month, I went to Kaggle. I took part in Titanic competition. I wrote some notebooks, and I have decided that okay, I'm ready. I'll go looking for a job. I failed. I failed very hard because no one's asked me about machine learning. People asked me, "Do you know what p-values are? Do you know about test statistics? Can you solve this mathematical problem? Can you write SQL query?" And I failed most of the things. So, well, it was a huge shock for me, but I realized that I need to study more. I made a new plan and started studying it. First of all, I have spent a week on SQL, knowing it. Then I opened Khan Academy and started again remembering the statistics. And then I have made some kind of list that nevertheless, I need to learn machine learning better. At the time in 2016, there were not many courses about machine learning. So I just looked for blog posts in internet and tried to do something by myself. So for example, I have decided now I want to study how to do regression. I Google, I find, for example, 5 or 10 articles in the internet. I find several notebooks on Kaggle. I read all of them. I try to understand all the stuff, and then I take some as data set and try to apply everything which I learned there. Then I write notebook and put it on GitHub. And I have studied for a couple of months. In total, I think I have maybe there were 50 or more contacts with companies. Contacts when we talked. So when we didn't even talk, I don't count it. There were at least 10 interviews. There were maybe 5 or more take-home tasks. And only after all of this, I was able to get a first job in the bank. So it was in total it took me 8 months to switch career from consulting to data science. If we talk about nowadays, I think we need to understand that knowing statistics and mathematics is a hot topic, and I'm not sure how I feel about it, because on the one hand, you really need to understand the theory. On the other hand, you rarely need to use it in practice, because, for example, I have almost 5 years of work in data science, yes, and from statistics I used maybe type 1 and 2 errors, p-values, and once I used statistics. I think I didn't use anything else from statistics. I used, of course, math for understanding backpropagation, stuff like that, but I don't use math every day. Yes, so while it's important to understand the machine learning models and to understand the basic stuff, in practice you don't always use it. So you need to know the basics, but you don't need to spend like half a year on studying it because you will hardly use it. Of course, there are companies where you need it, but not. Another important thing is software engineering, because you need to be able to code. But again, how much do you need to code? Some people may say that you need to be able to do open op. You need to be able to work with JIT. You need to know everything, right? But well, I think at my first 4 jobs, I have used Git only a handful of time. On not my current company, I'm using Git usually, well, almost daily. Yes, so not every company is developed enough to support good engineer practice. So I think you need to be able to code, but you don't need to be able to be a pro. And there is one another thing to consider, that I think there are 2 very different paths. One part in working with tabular data with classical machine learning problems, and another in using deep learning. Because to be honest, if you are working with deep learning problems, you will hardly need statistics in practice. You will hardly need to know the assumptions of linear regression. Yes. So these are different things which require different skills. And there are different types of people, different types of companies working on these projects. So you need to decide what you want to do and try it. But of course, it's very difficult. For example, my first 3 companies had only tabular data. In the first company, I have worked both with tabular data and with text and images data. And currently, I'm working with text and images data only. So different companies, different requirements, different experience, something like that.
Got it, got it. So it's like not all organizations are at same level, and the way data science is used at different organizations is different, and that's why your career growth might differ a little bit, and what you need to understand, what you need to know. And just a follow up to your experience.
Sorry.
I couldn't get you. Hello. Hello.
There is something. Could you repeat the question, please?
Yeah. So the question is like a follow up to your follow up to. Yeah, sure. Like a follow up to your experience, it's like a lot of folks who are trying to shift their careers, like shift their career from consultants or from other job roles to someone who is like, let's say, who is an economist at certain organization. They are trying to get into data science, and they're too much worried that, okay, I don't have that much experience. Data science is too much to learn. But like it's important for them to understand that whatever knowledge that they have from their backgrounds, like someone is coming from arts, someone is coming from economics, so it's always better to build on top of that, like the domain knowledge that you have. So what's your view on that, like utilizing your domain knowledge which you have worked in the past, like someone who is into consultancy or someone who is into economics? Like it's always better to help to start from whatever they have built on the previous years. So what's your view on this?
Yes, I agree that if you have some experience, it's better than nothing. Because even if we don't talk about any domain knowledge, you still have some job experience, and this is better than some person who doesn't have any job experience. You know how companies work. You know how to work. Yes, and someone who doesn't have experience doesn't know this. It's first point. It's about experience. I also agree, but it could be difficult to leverage that experience at your first job, because when you're looking for the first job, you will likely solve some basic problems. So, but for example, for me, when I was looking for my first job, I wasn't really leveraging my previous experience. I was simply showing my knowledge of data science. But after that, I started saying, well, you see, I have experience in machine learning, but before that, I have spent 4 years in consulting. I know how to talk with business. I know how different departments work, and so on and so on. So I use this to leverage. And there is one additional idea. If you're working in a company and there are departments doing data science, maybe it's possible to switch within your current company. I know numerous examples of people who switch to data science within their company. They just know people, they were able to negotiate the switch of their career, and it's very easy because you don't have to pass the interview. You already know how everything works, and maybe you can even help the data science team thanks to your knowledge of some organizational processes and some other insider stuff. So if you have some previous experience and want to switch to data science, don't worry, you will be able to use the previous experience.
Makes sense. Perfect. Thank you for sharing this. Like definitely makes sense. And like might be while you were discussing us like three favored libraries in Python for data visualization, Plotly, Streamlit, and the third one was like Ramsey is asking for
Altair.
that.
Altair. It was three library
Okay.
for visualization, and the third one is Altair. As I have said, it's about the grammar of graphics. It's similar to ggplot2, and it has really good capabilities.
Perfect. Thank you. Like while we close this session in the next 2 minutes, like the last question would be around how have been your journey with Kaggle, and like a lot of folks are interested that okay, how it feels to be a grandmaster and how has been your journey on Kaggle. So around that.
Well, I think, my journey on Kaggle started with Titanic, as I have said, in 2016. But at the time, I have thought that, well, I don't need it right now because it really doesn't help me to find my job. Then I have found the first job, and I have a lot of things to learn which are very practical. So I didn't have time for Kaggle. So I returned to Kaggle in 2018. I took part in the first competition and we got a bronze medal, but it was very useful. And at the time, I have understand that when I work in the company, it's difficult to compare your skills to others because I had a small team. It was difficult to compare with other people. So I wanted to see whether my analysis is good. And I started writing notebooks because I wanted to, first of all, compare my skills with others, and also I wanted to get some feedback on them. So, and I got some positive feedback. I realized that some people like my analysis. I started writing notebooks more and more. And after some months, I have realized that, well, maybe I have some chances to go higher in the rank. I think it took me a year of actively writing these notebooks to get the Grandmaster rank and some time more to get to the first place. It was an amazing experience because I learned really a lot of things. First of all, is being able to learn new things fast because, there, for example, today starts a new competition. Aha, I want to write a notebook. I need to stop doing something, everything. I need to understand what is this a competition about? What is this data? What do we need to solve? So it's like I need to produce this notebook within several hours, and this really pushes your ability to learn new things, to adapt, to work with the new types of the data. I really liked it. Of course, I got a lot of people who I knew. It helped with networking. Obviously, it helped with data visualization and machine learning skills. And being the place, well, the first place, sitting at the top first place was really fun and cool. I could say that I'm top one in Kaggle, so later I had said that not in competitions. And I'm really glad that I was able to become master in competitions. I'm not sure I'll pursue the Grandmaster rank in competitions because it requires a lot of investments, especially nowadays when the competition is very fierce. But taking part in Kaggle notebooks in competitions was really fun. It taught me a lot of skills. It helped me with some kind of creating my personal brand. I don't regret any time spent on it. It was very useful.
Got it, got it. Thanks for that explanation, and it was really inspiring journey. Thanks, Andrey, for joining us today. And we will share the slides of Andrey to all the registered attendees over our GitHub profile. So do check out that. And thanks, Andrey, once again for joining us, and stay safe. Bye-bye.
Thank you. And thank you for holding this talk.
Thank you.
Bye.